In the last video, we didn't finish a question when we're looking at identities. So start from there and then proceed with the task for this video, which is to do more of equations. So we had an identity. I think we'll do two more. So we're looking at questions from sheet 5. Questions from sheet 5, and the question was prove. That was question 8, part F. So we're proving the identity 1 over 1 minus sine x minus 1 over 1 plus sine x. That this side is equal to 2 tan of x and sec of x. So the proof is going to be here. So as usual, we'll pick what looks to be simplifiable. So we'll pick the left-hand side. If you look at the left-hand side, we have two fractions that we should subtract. The second from the first. So get the common denominator, which is 1 minus sine x. We multiply it by 1 plus sine x. Now what do we get from there? So up as we divide, we get 1 plus sine x multiplied by 1, which is 1 plus sine x, minus 1 minus sine x. Okay. The next step is we simplify the numerator, which will be 1 plus sine x. We expand the brackets there, so it will be minus 1 plus sine x. Now the denominator, if we expand it, because the difference of two squares, we have 1 by 1, which is 1, 1 by sine x, and then negative sine x, and then negative sine squared. So if you look at that, what are we getting? So on top, we're getting 2 sine x, since 1 minus 1 is 0. And down, this will cancel. So we'll have 1 minus sine squared x. Then the next thing is we realize that the 1 minus sine squared x is the same thing as cos squared x, which you can write as 2 sine x over cos x multiplied by cos x. So we can even introduce a 1 up there just for us to see that the 2 remains there. Then the sine over cos becomes tan, and the 1 over cos becomes sec, which we know is the right-hand side. So that's how we get the proof of that one. So we proceed to G, which is the last part on question 8. So G, we're supposed to prove that sine x minus cos x, if you close the brackets and square, then you add sine x plus cos x, you close the brackets and square, that you should get 2. Now, if you look at this, we again pick the left-hand side, because I mean, how do we start splitting 2 to give us this sine, cos, and the like? So we can simplify the sine, cos, and see if we'll get 2. So of course, what we need here is to just expand these brackets. So the first bracket, when we expand, we're going to get sine squared x minus 2 sine x cos x. And then plus cos squared x. Plus, when we expand this, we're going to get sine squared x plus 2 sine x cos x plus cos squared x. So what are we getting here? So if you see this and that will cancel, then we have sine squared x plus cos squared x. We know that's 1. We have sine squared x plus cos squared x. Again, that's 1. So the 2 will give us a 2. So when you add the 1, you get a 2. Which was the right hand side, the other side. Okay. So this that completes the proofs of the question 8 of this tutorial sheet. So now we can go to question 9 and look at the equations. So we look at the equations. So let's see. We go to question 9. Question 9, the target angle. So we're given an interval. Whatever we do, our angles must be between 0 and 2 pi. So this is the interval of our angles. Okay. Now this is the same as saying it must be between 0 and 360. So we start with part A. So part A has sine 2x minus sine x is equal to 0. The solution. So what we do here is we split the sine 2x. Since this is a double angle, we use its identity, which is 2 sine x cos x minus sine x are equal to 0. This implies that we can factor out sine since it's common, then we remain with 2 cos x minus 1 equal to 0. So this means it's either sine x is 0 or 2 cos x minus 1 is equal to 0. So the only way a product of two things can give you 0 is when one of them is 0. Now we don't know which one is 0 here. So we are saying, oh, it's either sine x is 0 itself or 2 cos x minus 1 is 0 for us to have a product giving us 0. Now, if sine x is equal to 0, then what values of x are those that gives us 0? So we know that the first should be 0 because sine 0 is 0. The second should be 180 because sine 180 is 0. Now I'm responding in radians because we're dealing with radians as an interval there. And then it will be 2 pi because sine 2 pi is 0. Okay. Then from there, we go to 2 cos x minus 1 is equal to 0, meaning cos x is equal to half. Now we must look at which angle gives us half. Of course, we start with the first quadrant. So where in the first quadrant do we get a half? So for cos, remember the angles, we are thinking of only two options where we get half for cos. So we have 60 here and we have 30 here. This is the root of 3. This is 1 and that is 2. And we are dealing with cos. So if you look at cos 60 here, cos 60 is, remember from SOHCAHTOA. So cos 60 is adjacent over hypotenuse. That is cos 60. So if it was cos 30, you would say adjacent over hypotenuse. So now we're interested in what gives us half. So we've seen that it's 60. So in the first quadrant, it's 60. So x is equal to 60 in the first quadrant. Now, where else is cos positive? Where else is cos positive? In the fourth quadrant. So in the fourth quadrant, it will be what? It will be 360 minus 60, which is 300. So we say 360 minus 60, which is 300. So you can convert these to radians. So you multiply by pi over 180. You multiply by pi over 180. So here we see that this is just pi over 3. Then here, again, we do the same. So we have, what do we have now? How many times do we get? Okay, let's use 6. So 6 goes there 5 times, and 6 here 3 times. So it will be 5 pi over 3. So it means that we have found all our angles. So we have found all our angles there. Okay. So we can go to the next question. So the next question is going to be B. Is it? Okay, yeah, B. So B is sine 2x is equal to the cos of 2x. Okay, I think we looked at this already, where we did divide by cos 2x, and we did divide by cos 2x, and dealt with the tan of 2x equal to 0. I mean equal to 1. The tan of 2x equal to 1. And we're able to find the angles using 45. Then you go around, you will check where it is positive, and remember that you're getting double because you have a 2 there. Okay, I think we did this. I remember. So let's go to C. I think we never did C. So C, we have cos. We have cos squared x. No. For C, we have cos 2x. Why am I getting confused? Okay. So part C, 9C is cos squared x minus sine 2x is equal to sine squared x, like that. Now, if you look at question 8, A and B, question 8, A and B was giving us the options on how to get the split of the identities of cos and sine. Okay, so if you look at this question, we're going to rearrange it to be in this form. And then here we have sine 2x equal to 0. So what are we doing? We're going to change our cos into sine form. So we have 1 minus sine squared x minus sine squared x. And then you write this to 2 sine x cos x equal to 0. And then this will give us 1 minus 2 sine squared x minus 2 sine x cos x equal to 0. Okay. Then now we check what we have here. If you look at um, part A, so part A has cos 2x. So part A is saying, we have this identity from question 8, part A. We know this identity even if we didn't have question 8. So cos 2x is equal to 1 minus 2 sine squared x. So it means that here we put cos 2x. Then now this means that we must take this back to sine 2x equal to 0. Why? Because it's going to be difficult for us to have cos 2x and then we have the sine x and cos x. It's better we have cos 2x and sine 2x because then we can take the sine 2x the other side and bring it back by division. You get that? So this will go this side. And then when you divide, you can divide either way. So because of question B, so you can divide by cos so that we solve the same question. So we are going to have 1 is equal to tan 2x. That is right. This is the same thing as tan 2x is equal to 1. That's the beauty of being able to have many identities, because then you're able to play around any given situation to take it to a situation that you can easily solve. Okay? So now, also because I didn't do part B there, maybe we can finish up part C here. So we're saying which angle gives us 1 for tan in the first quadrant. So we know that this means that 2x should be equal to 45 because tan 45 is equal to 1. So 2x also should be equal to what? So 2x also should be equal to what is 45 in the in the third quadrant where tan is positive. So it would be 180 plus 45. That is 225. We divide by 2. So x is going to be 22.5. X is going to be 1 what? So I'm now dealing with 225. So it will be 112.5. Now these angles, they are giving us space to even go outside. To even go outside the first set of the quadrant. Remember, we have gotten 1, which was 45, and broken it and divided it by 2, meaning what we have now is a small angle, which is 22.5. Now we have another angle that would start from the very point this guy is starting. I want the color. Okay, that would be the very it will start from 0, go around and come to end at the very end point. This angle is called a coterminal angle to 22.5. So that coterminal angle will also be part of the solution here. So you say x is equal to 22.5 plus 360. Okay. So plus 360. So now, for us to get it easily, excuse. So we won't use, so when we go to the coterminal angle, because this one then is going to be beyond 360. So what we'll do is we'll use the 45, not the 22.5. So we'll do this. We're using uh, we're using the 45. So use the 45. Which one? This one. So use the 45. We start from here, go around, come up to there. So do 360 plus 45 and call it our 2x. So our 2x is going to be, that will be 4,405. And then divide by 2, divide by 2. So the value we get will be in the required interval. So we'll get x is equal to, what is it? So it will be 405 divided by 2, which is 205, 202.5. So what we want here is to be within the required interval. Remember the interval given from 0 to 2 pi, so from 0 to 360. So because these angles, even if I went outside the given interval, I'm still going to divide by 2 because the angle we're having, the initial angle is a 2x. So because we're still dividing by 2, then we can overshoot 360 and still come back when we divide by 2. The reason why I didn't use 22.5 because 22.5 is already divided by 2. So if we used it, then what we get must be the actual solution. So that's why we are skipping there. Okay. Then we got the next. So the next we'll use the 225. So it will be 225. Where do you find 225? Here. So that angle up to here is 225. Then now we need a coterminal. A coterminal that runs from there, comes here, go beyond and get back here. So meaning it will be 360 plus 225. So 360 plus 225. That is 585. Then divided by 2. So it will be another value of x, and it's going to be 292.5. So now I'll leave it for you now to convert this to radians. Okay, how do you convert? So the first one we said x is what? 22.5. So you multiply by pi over 180. The second one is, or maybe you will see that, okay, this one might be too complicated for you to start dealing with decimals. So you can just say, okay, what I would do is I'll say x is equal to, we know 45 already. 45 is pi over 4. So you just write it as pi over 4. Then you multiply by half, which is going to be pi over 8. The second thing, you had your 4. So there where we were doing the addition. So we're saying that was 405, which was 360, which was 2 pi plus what? It was 2 pi plus pi over 4. So this very situation is what we're dividing by 2 to give you 205. And then the third one, we had x is equal to what? 225 divided by 2. What was 225? We said pi plus pi over 4. And then you divide it by 2. And then the last one is we added 2 pi plus what? Plus 225. Now 225 is 5 pi over 4. Is it? Yeah, 5 pi over 4. It was 5 pi over 4 over 2, so it was 5 pi over 8. No. Yeah, so 5 pi over 4. That is the sum. And then you divide the sum by 2. So these will be your solutions. This one, this one, this one, and this one. So we have 4 of them. So the key thing is whenever you notice that there's a double angle, then you know that even my angles will be doubled. I don't just get the initial ones from the first quadrant. I also think about going outside and get the coterminal. So if it was 3 there, would have gotten 3 angles per angle. So the first angle, I get this, the coterminal and another coterminal. Because we must cover the whole interval. We don't leave anything in the interval. Okay, so that was part B and part C. I think they'll did the same thing after evaluate the other one. Okay. So I think most of it. Okay, I think we did part D, the cosec part, where we did the square root. We did part E. Yeah, we also did part F. Okay. So that's fine. Then maybe we can do some from question 10. From question 10, we have find all solutions of the equation in the interval 0 to 360. So the first one, yeah, the first one is nice. It is 2 cos 3x equal to 1. Interesting. So 2 cos 3x equal to 1. So this means that the cos of 3x is equal to 1 over 2, like that. Okay, so we have cos 3x is equal to half. Now we must think about which angle gives us half for cos. So for cos, I think we had a question where we're looking at what value uh, of the angle will give us half for cos, and we found out that it was what? It was 60. So we know that 3x is equal to 60 in the first quadrant. Remember, the interval is from 0 to 360. So now, what is the other angle within that interval that you can equate to 3x? So we have another angle, 3x is equal to what? 300. Because we're dealing with cos, so cos is positive in the fourth quadrant. So 360 minus 60 will get 300. So man, this means that the first value is going to be at 20 degrees. And here, the first value is going to be 100 degrees. Now, if you look at the space, we have 20 and 100, but we must cover from 0 and 360. So we still have other options. Now, because it is 3, we know that we need 3 at each point. So we need 2 more from this x is equal to 20. So we get the coterminal. So we come back and say, okay, we also have one that will, so this is the first solution. The second solution, we are saying it will come from 3x is equal to 60 plus 360. And then we'll divide it by 3. We'll divide it by 3. So we have gotten the first coterminal. So x is equal to, that is 420 divided by 3, is it? Well, let me be sure. So that will be 60 plus 360. Yeah, 420 we divide by 3, we get 140. So we have the second solution. That was the first solution from that. The third one, we go again. So do 3x is equal to, we got, so it was 60 plus 360 plus 360. This is the second coterminal, okay? And then we'll have to divide it by 3. So that was 60 plus 360 plus 360. That's 780. And then we divide it by 3. We divide it by 3. So we have x is equal to what? This guy divided by 3, we get 260. Now, in case you're not so sure, okay, you feel you can check, what if I can add again? You can try to add again. So when you add the 360, then divide by 3. Okay, so if you try to add again, it will be 3x is equal to 60 plus 360 plus 360 plus 360. And what you will get will be that the total should be 1140. When you divide by 3, your x is going to come out to be 380. Now 380 goes beyond the given interval. So it means that we don't go that far. So if I'm dealing with 3x, then I'll just get the first one, second, third. Okay, so this one is not needed. So let's go to part where there's 100 there. So this was our first solution, and that's it. The second one is 3x is equal to 300 plus 360. Then we'll divide by 3. We'll divide by 3. That is, x is equal to 300 plus 360 equal to 660, then divide by 3. So we'll get 220. Second solution. And then third, let's see. So we have 300 plus 360 plus 360. And then we'll divide it by 3. So what are we getting? So plus 360. So we're getting, then we divide by 3. So we're getting 340. Okay, so it's okay. So 3x is 1020. Then divide by 3, divide by 3. So we have x is equal to 340. Okay. So we have these as our solutions. So 1, 2, 3, 4, 5, 6. Wonderful. Okay. So that was part A of question 10. Let's go to, I think we did B for sign. Oh, let's do it. So let's do it. So we're going to have B 2 sine squared 3x minus sine 3x minus 1 equal to 0. So the issue here is, this is like a quadratic. So I want to let y be equal to sine 3x. So that we deal with 2y squared minus y minus 1 is equal to 0. Like that. So that we check what's our product. Our product is -2. So what the sum is -1. So what should be the factors? So the factors will be -2 and +1. So that we put here, so we have 2y squared minus 2y plus y minus 1 is equal to 0. And then we have 2y, so that we get y minus 1, and then plus 1, y minus 1 is 0. So meaning, we have y minus 1 being multiplied by this guy. So we get y equal to 1 or y equal to minus half. Y equal to minus half. So easy, is it? So when y is 1, remember our y is sine 3x. So it's equal to 1. So you check again, what gives us 1? So for sine, we know that sine 90 is 1. Very good. Sine 90 is 1. So we have 3x equal to 90. So that we get x is equal to 30. The first solution. Again, 3x is equal to 90 plus 360. Then divide by 3, divide by 3. So x is going to be, so you just repeat what we are doing in the course part. So this is 90 plus 360 divided by 3. So that will be 150. The third, it will be 3x equal to 90 plus 360 plus 360, which is 810. 810 divided by 3. That will be, this will be 810, so that your x becomes 270. Okay, then we go to the next one. Sine 3x is equal to negative half. So you know that for sine, if it was in the first quadrant, it should have been 30. Now it's not in the second quadrant either. Second quadrant would have been 150. But in those quadrants, sine is positive. So it means we want 3x to be what? To be in the third quadrant and in the fourth quadrant. So in the third quadrant, it would be 180 plus 30, which is 210. Okay? Then in the fourth quadrant, it will be 360 minus 30, which is 330. So again, we are still dividing. So we divide by 3, divide by 3. So the first x is going to be 210 divided by 3, which is 70. This will be the first x. The next is going to be 210 plus 360. Then we divide by 3. So it will be 570. Then we divide by 3, divide by 3. We are getting x to be 190. Third, it will be that plus 360 again. So it will be 3x equal to 930. When we divide by 3, x is going to be, it's what, 930? We divide by 3. So you get 310. So from this 210 alone, we have those 3 solutions. Then we also check in the fourth quadrant where sign is negative. So for 1, we only got one set because we didn't have the negative part. Yeah, we didn't have the negative part. So now we go to the 330. We divide by 3 again. Divide by 3. So we have x is equal to 110. Then we come back and add 330 plus 360. That is 690. Then divide it by 3. So divided by 3, we'll get 230. Then again, 3x is equal to 1050. And then divide by 3. That will be 350. So this question demanded how many solutions? 1, 2, 3, 4, 5, 6, 7, 8, 9 solutions. Imagine if you missed out 6, you only went for sine 3x is equal to 1. And then you discover after the exam, you'll be stressed because you know 6 angles should carry a lot of marks. Okay, so you must be very careful whenever you find that it's not just x, it's 2x, it's 3x, it's 4x. So if it was 4x, would have gone 4 times per piece. Okay, I think this should be enough for this part. Let's look at C. Maybe C, I'll leave it somewhere for you to finish. So C is 4 sine x cos x is equal to 1. So look at that. So you'd think of maybe I divide by 4. But remember the identities. Because I have a product of sine and cos, that product of sine and cos should remind me of this. Because this sits like 2 sine x cos x. So whenever I find the product of cos and sine, I must first think about this guy. Okay? So meaning you write this as 2 multiplied by 2 sine x cos x equal to 1. You understand? And then this now becomes 2 sine 2x is equal to 1. So that you get this. Okay? So now you've gone into the sine 2x is equal to half. I think we did this. Did we? Did we do that? I think we did. Um, oh, okay. So we are doing, it was tan, and then it was cos 3x, and then sine 3x. Okay, so now for sine 2x, just at the angle here is what? The angle is 30 for sine, and then you're using 2x, not 3x. So you got twice. So you check because it's sine positive. So you're getting 30 from the first quadrant, and you're getting 150 from the second quadrant. Then you get how many? One more. So you get one more. So you have 4 solutions. So your 2x is going to be 30. Also your 2x is going to be 150. So when you divide by 2, you get x is equal to 15. That's the first one. Here, x is equal to 75. The first one. Then you do the coterminal now. So go for the coterminal. 30 plus 360. Then also 150 plus 360. Then divide and then C. So that will be exercise in understanding part B. Then you do part C. Okay. So part D also is part of your exercise. So part D, root of 3 sine 2x is equal to cos 2x. So again, this one, you want it to be the root of 3 sine 2x, then you divide it by cos 2x equal to 1, so that you remain with tan 2x equal to 1 over root 3. Then from here now, again, it's an exercise. It's a double angle of tan. You know 1 over root 3, where it's coming from. So you can get that from the triangle. I gave a triangle here. Here's a triangle. You want tan. You want tan. So you don't know what is here, but on the right you have 1 over root 3. So that is adjacent over. Tan is opposite over adjacent. So meaning it's going to be 30 here because you're dealing with the opposite of adjacent. So you have your theta as your angle, and then you go and say, oh, okay, so 2x is equal to 30 in the first quadrant, and 2x is equal to what? You go in the third quadrant, you add. So it will be 180 plus 30, which is 210. And then now deal with those. So you have double. So you divide and then come back, get the coterminal. Come back, get the coterminal, and see until you cover a given interval, which is 0 to 360. Okay, so that was on equations. I think this should be okay. Then we did question, did we? Yeah, we did question 11. We did question 12. We did the sketches. And the remaining ones I gave you as a task, as an exercise. Then we did question 12. Yeah, we did question 12. We didn't do question 13. So I think I can comment on question 13. So given the intervals, given that the range of the functions sine inverse, cos inverse, no, there are only two, sine inverse and cos inverse. So for sine inverse, the range is negative 90 to 90, cos inverse from 0 to 180. Then you are given that we should evaluate sine of cos inverse of half. So this should be very easy to do. You go inside. So these two, they are sitting. One is the angle for the other. So like part A, the angle here is cos inverse of half. That is the angle. So when I find that angle, I must take it in sine and get the value. So if we let our x be equal to cos inverse of half, then this question now has become sine x. So when we know our x, we'll come and put it there and find the value of that sine x. Okay? Now, if I have this means that this is the same thing as cos x is equal to half. You get it? Now, if cos x is half, then where is that x? Okay? What is that x? So, that x is 60 for cos. The x is 60 for cos. Then I check, what is the given interval for cos inverse? For cos inverse, we are given from negative 90 to 90. So 60 is enough there. So when we get 60, then we go to sine and say, oh, okay, so now we know our x. So what is sine 60? So sine 60 is going to be root 3 over 2. Okay, very interesting. So we go to B. B now is cos sine inverse of what? Of half. Oh, okay, so again, we let x to be sine inverse of half, meaning we want to find cos x when we know what x is. So this is the same thing as sine x is equal to half. So for sine, x is going to be 30. What's the interval for sine? The sine for sine inverse. Oh, so in fact, for sine inverse, for cos inverse, it was 0 to pi. That was fine. Then for sine inverse, it's negative 90 to 90. So again, that's fine. We'll deal with the 30 there. Okay, so when you deal with the 30, then we take cos 30 here. so that we get what? We get half. Now, what is cos 30? So cos 30 is root 3 over 2. I'm surprised we're getting the same value. The other one is sin 60, the other one is cos 30, but the values are the same. We're okay with that. Okay, so I think this should sum up the whole tutorial sheet for trig where there are need areas. Unless otherwise, you can inform me if there are any other parts that we need to do so that in our next class, we should go straight to exponentials and logarithms. So if we move as fast as we can with understanding, even better. Okay, thank you.